Hello friends, welcome to another episode by Engineering Today, and we hope that you're all in good health. Let's begin our news with SpaceX's Super Heavy Booster, BN3. SpaceX had stacked a Super Heavy Booster prototype, BN1, to its full height earlier in 2021, but due to changes in the design, BN1 became obsolete, and SpaceX team scrapped it. BN1 only became a pathfinder in SpaceX's Super Heavy Booster making. BN2 has also come into view in SpaceX's assembly line. Now time has come for orbital Starship launch preparations. SpaceX has begun the process of stacking the first Super Heavy booster capable of supporting orbital Starship test flights. The Super Heavy booster is BN3, booster number 3. Recently, over the last month, various structures and portions of the 70-meter tall steel booster have been spotted at SpaceX's Boca Chica factory. It's assumed that within just 90 minutes, Starship's first orbital test flight will fly nearly over 3/4 of the world after getting launched from Boca Chica launch site. On successful completion, Starship will gently splash down near Kauai, Hawaii. It isn't known whether SpaceX will attempt to recover Super Heavy booster BN3. SpaceX has nominally assigned Super Heavy booster BN3 and Starship vehicle SN20 for supporting the first orbital space launch test. Some reports say that Starship SN20 will not complete a full orbit, thus it's unclear whether the test flight will totally be orbital or not. SpaceX has already filed an application with the Federal Communications Commission in the earlier week for permission to communicate with Starship and Super Heavy during that orbital test flight. The application noted that the 6-month launch window is scheduled to the 20th of June 2021. It seems that hardware for Super Heavy booster BN3 is ready to get installed. Some integration procedures have also gone through. 8 stainless steel rings have been stacked, covering nearly 20% of the booster's full height. SpaceX has to assemble and stack the booster BN3 in such a way that it becomes flight-worthy by late June 2021. This first operational Super Heavy prototype will also have to complete several major tests before being cleared for orbital flight. SpaceX has completed the average part of the engine section of BN3. The thrust dome section was plumbing cutouts for 28 Raptor engines that have been made out. SpaceX has at least 6 BN3 sections rounding to 22 rings. They're also having 2 tank domes on the verge of completion and waiting to get installed. According to a report, SpaceX had started the process of stacking BN3 earlier this week when SpaceX first joined the twin 4-ring sections together with the booster's common dome. A Super Heavy fuel structure was also seen in Boca Chica. This fuel structure will be attached to the end of a Super Heavy transfer tube. A report says this Super Heavy transfer tube will be used to transfer methane through the liquid oxygen tank to fuel its Raptor engines. Fueling of 28 Raptor engines will need an input of 30,000 pounds of propellant per second at their full thrust. Transferring such a huge amount of fuel in such a short time needs a super-sized fuel structure. Thus, these structures are quite a good fit. A scheduled free return re-entry would make it almost absurd for Starship to reach orbit. It may fail to deorbit itself after 1 hour and 30 minutes journey in space. Thus, a risk to populated areas from falling Starship from space remains in mind. Regardless, it's clear that the specifics of Starship's first spaceflight attempt are still very much up in the air and liable to change over the next few weeks. SpaceX will now need to fully assemble and test Super Heavy booster BN3 and Starship SN20 before any potential space test within a short span of time. SpaceX still has a huge amount of work to do. At present, an orbital flight test of Starship by June or July seems implausible, but the pace of work for SpaceX makes it probable that both Starship and Super Heavy could be ready for their first orbital test flight very soon. Let's move to our next news based on recent modification made to SpaceX's Dragon XL lunar cargo resupply mission. News revealed last year that SpaceX is on track to develop a Dragon XL resupply spacecraft under NASA's Gateway Logistics Services (GLS) contract. As per that contract, the spacecraft would carry pressurized and unpressurized cargo, experiments, and other supplies NASA's lunar space station called Gateway. Recently, NASA announced some modifications regarding that mission. The agency suggested using the spacecraft as an extra crew cabin and bathroom at their lunar space station. Modifications were made around April 1st of this year, for which NASA provided $121,000 to SpaceX. Originally designed to carry at least 5 metric tons, about 11,000 pounds, of pressurized and unpressurized cargo to Gateway, the spacecraft will now serve beyond its primary goal. The Dragon XL spacecraft could launch on SpaceX's Falcon Heavy rocket. At the same time, NASA made it clear with their announcement that the agency wants to support its Artemis program with Dragon XL cargo deliveries. As per NASA, SpaceX would launch the Dragon XL resupply mission as early as 2024. Meanwhile, NASA's Human Lander system is in a work-in-progress stage. A week after the GLS announcement, NASA awarded $1 billion to 3 launch providers: SpaceX, Dynetics, and a team led by Blue Origin. Later, SpaceX became the only provider to secure the Lunar Lander contract from the agency. The news of selecting only one provider for HLS moon landing demonstration contract was not surprising if we consider the capabilities of SpaceX's Starship vehicles. SpaceX CEO Elon Musk believes that SpaceX's Starship could one day send humans to Mars, but before that it might be good to test it out on a lunar mission. According to NASA, SpaceX Starship HLS lander will dock with the agency's SLS-launched Orion capsule in lunar orbit. After that, Starship will land astronauts to the moon. So it's clear that the Orion capsule and the Starship will not be docking separately with the Gateway to transfer the crew. Thus, it raises questions about NASA's GLS contract. The concept of Gateway is nothing but a tiny space station. If the Orion capsule does not need Gateway to land astronauts on the moon, then what value it could offer in future, considering that it might end up costing $4 to $5 billion for NASA. The cost includes Dragon XL cargo deliveries, a Falcon Heavy launch of the first 2 Gateway segments, and a station production. As we know, NASA's HLS lander contract with SpaceX costs approximately $2.9 billion. The next cheapest alternative will be Blue Origin, which is expected to cost around $6 billion. If NASA stops its Gateway development project, then they could afford 2 launch providers without a larger budget. However, it's nowhere near that. Currently, SpaceX and NASA both are working on the modifications of the Dragon XL resupply mission. That's all for SpaceX today. Now let's move to our last segment based on ULA. Tory Bruno's United Launch Alliance recently launched its Atlas V rocket carrying a U.S. Space Force missile warning satellite and 2 small payloads to orbit. On Tuesday, May 18th, the 2-staged Atlas V rocket blasted off from Space Launch Complex 41 at Cape Canaveral Space Force Station in Florida. At around 1:37 p.m. Eastern Daylight Time, after a 24-hour delay. According to sources, the delay was caused by an issue with the rocket's liquid oxygen system. The weather was 90% favorable for Tuesday's launch, and liftoff of the United Launch Alliance Atlas V rocket with the 5th space-based infrared system satellite for the United States Space Force, stated Steve Huff, the launch director and commentator. The primary payload for this mission was Sibir's Geo-5, the 5th space-based infrared system geosynchronous Earth orbit satellite. Developed by Lockheed Martin, this satellite can detect ballistic missile launches anywhere on Earth by using its built-in infrared sensors. Atlas V also carries 2 CubeSats as rideshare payloads, which were deployed into orbit by the rocket's Centaur upper stage about 16 minutes and 30 seconds after the launch. 2 rideshare payloads, both 12U CubeSats, have released from Centaur's aft bulkhead into space. The technology demonstration orbiters are sponsored by the United States Air Force Academy to help in creating critical capabilities that support the warfighter, ULA stated on Twitter. About 43 minutes after liftoff, the rocket successfully delivered Sibir's GEO-5 satellite to a geosynchronous transfer orbit. Tuesday's launch marks the 87th launch for ULA's Atlas V rocket and 258th flight for Centaur. This venerable U.S. upper stage is the high-energy, hydrogen-fueled rocket that unlocked access to send robotic explorer spacecraft to every planet in our solar system, ULA stated regarding this launch. That's all for today. For more updates, stay tuned. Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.